Hi, my name is Mike Amundsen, and this talk is 5 essential API design assets. First of all, this is me. This is how you can find me on LinkedIn and GitHub and YouTube and Mastodon and Blue Sky and all those other social networks. I would love to hear from you. Most of the material I'll present today is something I learned from someone else, and I would love to learn from you so I can share it as well. Please connect with me and remind me where we met, and I'd be happy to connect with you as well. So first of all, I just want to mention the API lifecycle is pretty vast. It's actually kind of complicated. There are lots of things to do: design and build and publish and realize the value and maintain over time and then eventually retire. It's a long life cycle and it contains lots and lots of activities. For today, I'm just going to focus on the design element, that very first part of the life cycle that allows us to start thinking in design terms, thinking clearly about how we want to create our API. And that's going to be what we talk about today. But there are lots of other things that we just won't have time to talk about. So I want to focus on this notion of design assets. What does that really mean? Why is that important? So design assets are any digital resources that are created or used in the design process. And user interface design, or UI or UX, user experience design, has lots of assets. It could be color sheets, screen layouts, some guidelines on font and all sorts of other colors and complementary things. So we know that pretty well from the UI or UX experience. But design assets exist for everything. Everything gets designed somehow. The camera that I'm using, the keyboard that I'm using, the computer that I'm using, there are design assets for that as well. Design assets are an essential way to work out the parameters of creating whatever it is you're creating. And APIs deserve those design assets just as any other element does. So I want to focus on what I call 5 essential API design assets. I think these are assets every API project should have: story, vocabulary, diagram, description, and definition. And we'll look at each one of these in turn and explore what they mean and why I think it's important that every API have these assets handy. So with that in mind as an introduction, let's go. Let's start talking with the first design asset that I think every API should have, and that is story. Lorinda Mamo has said it best, I think: every great design begins with an even better story. Story is what we share. Story is the reason we're doing this work today, and story is always accessible. Often API stories start with, "we need X," or "our customers have requested Y," or "I just have an idea that this could improve the situation." That's the start of a story. Stories are shared understanding. Our brains are wired for stories. We don't really remember data and statistics very well, but we always remember a good story. Stories are also accessible. API stories that explain why why we're doing this and who it's affecting are something that everyone can participate in, whether you're the first day on the job or whether you're the CEO or CIO. Everyone has an idea of what the stories can be. And stories are repeatable. Once you create a good story for your API project, you can share it and repeat it, and others will share it as well. And that gives it a great deal of power. So there are lots of ways you can create an API story. I encourage people to simply use a Markdown document or some Google Doc or some Microsoft Word document that has these key elements: the purpose, a sentence or two which basically says what this API is all about. Ridley Scott, the great movie producer director, has this notion that he tells everyone: explain the movie to me in 2 sentences. If you can't do that, then you haven't thought it through enough. So let's explain our service, our API. And also, this story has all the actions we're going to create and get a list and filter the list and remove and update and so on and so forth. List all the possible actions. These are very, very important because these are the things people can do. Also listing the data elements in just a general way: given name, family name, telephone, email, so on and so forth, and any particular rules. There can't be two records at the same time, or you can't start a new order if you already have one in process. Whatever those rules would be, help with that story. Notice that this story has nothing to do with HTTP or GET or PUT or POST or React or JavaScript or C#. It's simply a story, an accessible story that everyone can connect to. Good API stories are always accessible to everyone. They're inclusive. All right, let's talk about the second element in this list, vocabulary. What do I mean by that? David Crystal says vocabulary is a matter of word building as well as word using. We're going to build an ecosystem. We're going to build a domain. We're going to build a vocabulary of words that everyone can share. What is an API vocabulary? It's all the magic words that are related to the API. It's not just ID and given name and family name. It's also create and approve and save. It's enumerators like status.active and status.inactive. It's containers like item and item.givenID and collection and list. And it's resources and topics, depending on what kind of API you're creating. The vocabulary is very, very rich. Domain-driven design from Eric Evans talks about the ubiquitous language that is shared between domain experts and developers. And that's what an API vocabulary is. Writing down each word is essential and sharing its understanding. And a vocabulary is very much like a dictionary. A dictionary has lots of words, but those words may have multiple meanings. Don't try to get everyone to share the same meaning of your vocabulary. Just make sure your vocabulary is well documented. Now, here's an example of that same API person service vocabulary that we were looking at earlier from the story. And I have done just the same thing we've talked about. Resources like home and collection and item, actions like create and remove and status and update and filter and so on and so forth, containers like person and properties. All of these things are actually done in the same way. Now, let's talk a little bit about the next step. Good APIs have a robust vocabulary. Don't be afraid to build out that vocabulary. So let's talk about the next item in our list, diagrams. We are visual creatures, say Steven Pinker. Our brains are wired to pictures. In fact, there are some brain studies that say when we're looking at a list of information, we don't actually store the list. We take a picture and store a picture of the list and access that list at some other time. So we're visual creatures. We need a visual representation of that API. And when I say a visual representation of the API, I'm not talking about a technical state diagram or a workflow diagram that shows how you navigate a certain set of steps or how you complete a certain set of tasks. I refer to it as an interaction diagram. Some people refer to it as a connection diagram. Here is an example of diagramming that same person API we've been looking at earlier, both through vocabulary and through story. Notice there are connections to things and there are activities that you can do along the way in each location. Some of them actually advance from one state to the next, collection and item and person and go and do and so on and so forth. This API diagram does not tell a person what to do. It just simply indicates what is possible, what the connections are. And by creating these kinds of diagrams, and you know, there are lots of tools. You can do this. You can do this as a mermaid diagram. I did this with a tool called an Alps diagram. You can actually draw it on a whiteboard with pencil and paper, all sorts of things. When you're creating this, what you're really doing is exposing the connections between things. Good API diagrams make connections visible. You want to show people how things are connected. All right, let's talk about the next item in the collection, and that is description. API descriptions are very, very important. And Jonathan Sachs of Harvard Business School has this great comment. Science is descriptive, not prescriptive. And we're going to think about the APIs the same way. We're going to explain what's possible and not tell people what they're supposed to do. We want to create a set of options. You can think of creating a landscape or a place where people can wander around and get things done. Now, why do I say descriptions? I didn't say definitions. And how is this different from diagramming? A description can be the complete design all in one place in one voice. You can think of the description as a machine-readable version of the vocabulary and the story that maybe results in a diagram. Who uses descriptions? Why do we have this notion of descriptions? Well, software architects can use the description to decide how to establish implementation details. Designers can use the descriptions in order to set up wireframes and other things like that. Developers can use descriptions as a guide as they're building certain parts of the system. Test security, all these individuals can lean on the description. And that means there are lots of different domains here. Designers, developers, testers, security officials. They don't all need to speak the same language or understand all of the same details, but they do need the same description. Descriptions also offer you a bit of time traveling. You can you can have a description that leaves some things off for the future. You can have descriptions that are of other versions in the past. Descriptions allow you to have a sort of general timeline view of how the project is moving along. Now, there are a couple of different kinds of interaction of descriptions, interaction-oriented and operation-oriented. I'll show you those right now. The simplest interaction-oriented description is probably just a table or a spreadsheet. Notice in this example here, I've got some resources and I list all the actions we talked about earlier. I even inserted a URL here because I'm looking at an HTTP implementation, but you don't need that information. Then I list the inputs and the outputs. And again, notice that I don't have things here like put and post and delete or details about GraphQL or details about event-driven architecture. Simply resource, action, input, and output. That's a connection-centric description. Another rather detailed description language is ALPS. I mentioned this earlier, the application level profile semantics description language that I and several other people have created. This is a diagram. This is a document that generates diagrams, generates stories, generates vocabularies, all the things we've been talking about all in one place. But that's not the only kind of description service you can use. There have been a few recently that I think are very powerful. One of them is called Smithy. The Smithy language is a code-centric kind of language. It identifies a namespace, a service, and a set of operations. Smithy comes from the Amazon AWS world. This is used to actually then describe all the things that we've talked about up to this point, the vocabulary and the story. Another example of a code-centric description language is TypeSpec from Microsoft, which looks very, very similar. It's got a namespace, services, and individual operations. So all of these are machine ways to describe in detail the prose and the diagrams that we've been working to up to this point. This is our opportunity to kind of focus in and center in on describing our API. Good descriptions, remember, provide the what and not the why. It says this is possible and you can do this. We're not saying why you should be using this API. That's something that you can think of yourself. All right, that leads to the last item in our list, the definition. How is definition different than descriptions? I love this quote from Tryon Edwards, a late 1800s preacher, philosopher in the United States. Most controversies would soon end if those engaged in them would accurately define their terms and adhere to their definitions. What is he really saying here? He's basically saying, once we've agreed on the details, most of the arguments fall away. And that's what we want to do. We want to have an accurate set of definitions for this particular implementation of the API. API definitions are our chance to translate the design into implementation details. API definitions are technology specific, unlike our descriptions and our diagrams and our vocabulary and our story, which are technology agnostic. So good API definition languages are OpenAPI for HTTP, Async API for event-driven, Protobuf for gRPC, Schema definition language for GraphQL. Each one of these are translations of the descriptions that we've had earlier. That's why I think it's so important to have a machine-readable description that's agnostic before you work on actually building up your implementation. Languages like Smithy and TypeSpec, by the way, will automatically generate these different implementation-specific descriptions. They're quite handy. API definitions are often referred to as generators. You can generate code from a definition. You can generate diagrams from a definition. You can often generate documentation from a definition. This is really not possible with description languages, but it's always possible with definition languages. So here's a good example in the Swagger editor of the Open API document for this same person service that we've been looking at all this time. So that's a great example of an API definition. It even generates things like documentation and other artifacts that you'll need in the final production API. Good definitions are explicit. Good definitions are actually leading toward the implementation details that make this API that we have this story about, to make this API real in real life. So we've gone through the 5 elements. Let's talk about them one more time. Stories. Every API begins with a great story. Vocabulary. We're building a vocabulary for our API. We're diagram thinkers. We're visual thinkers, and we want to create a diagram for that API. We want to be descriptive, not prescriptive in our description, and we want to be explicit in our definition. So story, vocabulary, diagram, description, and definition make up the 5 essential API design elements. And I want to leave you with this one last thought. Design is thinking made visible, by Saul Bass. This notion that where our design is really an opportunity to take the ideas that we've been working on, put them in some kind of form, in lots of different forms, as a matter of fact, so they're accessible to lots and lots of people. Who was Saul Bass? If you've ever seen the opening to the James Bond movies, the little eye that moves back and forth, and then the gun, that's called opening credits. That was designed by Saul Bass. If you've ever seen the Pink Panther movies, the little cartoon opening credits were designed by Saul Bass. Saul Bass was a great designer and a great thinker and a great entertainer. So that's what I have for you today. 5 essential API design assets. Hopefully this gives you some ideas on how you can apply this notion of design assets to creating your APIs. Thank you very much.